Hello everyone and welcome to today's webinar on travel and motion test on MV/HV circuit breakers. My name is Sanjay Yadav and I'll be hosting this session today. Speaker for today's session is Mr. Ali Hussain, who is an application engineer at Mega Middle East. Before handing the mic to Mr. Ali, I would like to highlight a few points. You all are being muted to avoid any disturbance during the presentation. Do park any question you may have for the Q&A session at the end or share it in the chat window. All questions will be answered at the end of the session by Mr. Ali. We also have a mega page on Facebook and LinkedIn for Middle East. I will just share that in the chat section. You can go on the link and follow us for regular updates. We have a lot of upcoming webinars in 2021. You can go on the link. I've just shared that in the chat section. You can register yourself for the upcoming webinars. Also, there will be a small survey form at the end of the webinar, so please do fill the same for the feedback regarding the webinar. The recording will be sent to you in 2 working days through the GoToWebinar system as a standard process. I now hand over the control to Mr. Ali. So let's get started. Over to you, Ali.
Thank you very much, Sanjay, for the introduction, and welcome everyone for this webinar today on travel motion test for circuit breakers. Again, I would like to highlight a very important point. If you have any question, please feel free to add that question into the control panel you have on the right of your screen. So without further ado, let's start. Today's topic is going to be very heavy loaded with many things I will talk about regarding travel and motion test. Some of the agenda will talk about why do we have to do the test. Also, we'll show some case studies, things that we have done and found why it is important actually to do this test. And also, how can we do this test? What does linear motion or angular motion mean? What does the transducer that we use for motion measurement mean? How can we mount this transducer, and so on and so forth? And then in the end, we'll talk about some of the solutions that we can provide for you to be able to do this test. And at the end, I'll answer any question that you may have arise during the session. So let's start by defining what is travel motion measurement mean. Travel motion is basically capturing using a transducer or travel transducer in specifics the moving parts in a circuit breaker mechanism. Usually in your circuit breaker, you will have interrupters inside an insulating media like SF6, or in the old days you have oil, minimum oil or bulk oil, and also there is air blast type circuit breaker, and also in the medium voltage more commonly you find vacuum circuit breaker as well. These interrupters are moved using an operating mechanism. So I capture this motion of this operating mechanism to assess and find if there is any problem or issues with this mechanism. It's basically a mechanical test to the operating mechanism of this circuit breaker. Usually this test is done on the manufacturer site, but once the equipment is being issued to the end user, being commissioned, maybe in the commissioning also they do it again, or then later on in the routine test, it is not something usually done. I found that at least in our region, I don't know about other regions for that. So today we'll be mainly focusing on doing it as a routine test, or as something to do periodically to find if there is any problem or if there is any issue. And we will mainly talk about this. So this is the more focused area for it. It's not for manufacturers or for people who do commissioning, but mainly for maintenance, and why should we do that. So this test basically is capturing motion, it comes in a distance, a value that the contact travel from one place to another place. So what parameters I can get from this travel motion measurement? A lot, actually. For example, this is a close open operation or double operation, where I close the breaker and I open it immediately. I put this graph so we can see for open and close operation what measurement we have. Basically, here I have my timing test. Here, when the breaker, the thick line is when the breaker is closed, the thin line is when the breaker is open. It was open, I closed it, and then I opened it again. So during this operations, my motion started from one position, went all the way up into the closed position. It was in open, then went to the closed position. The whole length of this measurement, we call it the stroke. This is the first parameter I can get from my motion test, the stroke value. Another parameter I can get also is over travel. From the beginning of the operation, for example, the close now, until the end, this is the stroke value. But in a lot of cases, the circuit breaker could over travel and then just bounce until it reaches its final position. This increase value of the motion or measurement is called over travel. And also penetration. Basically, this is after the closer, when my first contact touch, until the final position. We call it penetration of the contact. We can also measure that value as well. Additional thing is when you have a lot of bouncing at the end, because usually once your interrupter reaches its final position, there is something will hold it called dashboard. There is any bouncing happening, you can also found it from the rebound parameter as well. In addition, and last thing you can get also from motion measurement, since you already have the distance value, the stroke, and you have the time, you just divide them in each other, the distance over time, you will get the speed. But that's not something directly we get it just by division, but there is a way to calculate the speed according to a certain points, because I cannot start calculating the speed from the beginning, because it is changing or accelerating until it reaches a constant speed. And also there is something called arcing contact length. We'll talk about this when we talk about dynamic resistance measurement. We can find it as a parameter from the motion or travel motion test. So a lot of information you are missing by not doing the travel motion test. And regarding that, why you should really do this test is not only because I'm telling you to do it, but also the standards recommend doing this test. IEC standard and also IEEE standard added as an optional, but it's something that really recommended to do. Another thing is that timing test only, which is what's mainly commonly done, timing and contact resistance for circuit breakers, does not tell you everything about the breaker, because if you look at timing test from even the standard definition point of view, it's just the time from the start of the operation, energizing the coil, until the contact, first contact separation or first contact touching, depending on the operation, close or open. So whatever happened after that or before that is not really being told by timing test. More information, as I shown you by the parameters in the previous slides, and also you can create a trending to your circuit breaker mechanism, as it's a huge part or the biggest part that really fails mostly in circuit breakers. So in order to give you even more insight or why it is important to do a motion or travel motion test, I have two study cases showing the benefit of doing a motion test. The first case, study case number one, is that they have a dashbot. Its dashbot is basically a damping device. It's used at the end of the travel or interrupter motion to stop the interrupter after closing or opening the breaker. This dashboard has failed and needed to be replaced. It has so much rebound, it has so much bouncing or so much jerking movement at the end of the operation. When they did the motion test, they found this at the end after reaching the final opening position. The bouncing was much higher than accepted. It was up to 11 millimeter, which maximum value defined to this circuit breaker by the manufacturer is 5 millimeter. Now they did then replace this dashboard and did the test again. The dashboard was over adjusted again, and now the breaker, instead of rebouncing, it didn't have any rebound in it, but the whole stroke, the whole value from the beginning to the start to the end of the motion has become less. It under travel. It's not reaching to the full open position, which is really something serious, because restriking could happen into that. And also the insulation property, it really depends on how further the two contacts are away from each other. So this is a very important thing to know. One thing I would really like to note is that even after readjusting the dashboard, the timing test, which is indicated by these three lines here, didn't really change its value. If I go to the previous slide, it's around 26 to 27 millisecond between the three phases. And again, even after adjusting the dashboard, the timing didn't really change, because we did not do any adjustment to the mechanism, or it's the springs that opening or closing the breaker. We just did to the end part of it, the dashboard. So doing only timing test will not give you this information about the dashboard. So even with this over adjusting, then they readjusted again, and the comparison between the two values, the blue and yellow one, is shown here, where the stroke has reached again to its nominal value. Now, in all these tests, the trip times is still the same. It didn't change at all. So this is something to note about a motion test. Another case study, they did another case study case two, as they did only a timing test, and everything was showing in the pass region. The values for the interrupters is within the accepted limits. It's all showing very good and promising. This is two break pair phase breaker, where you have two interrupters for each phase. This is usually used in very high voltage application. Now, if you see this, you'll say this breaker is working fine. There is no problem to it. They said, let's add motion test again to this breaker. So they did the motion test, and the motion test was done on all three phases, because this breaker is a separate mechanism. Each phase has own mechanism. They found out that phase B motion is going really different from phase A and B. You can see phase A and B is the red line here, and phase B is going way further over them. It's really over traveling, and it is actually faster than phase A and B. All of this is not indicated in the timing test. Okay, they can only see it through a motion test. When they over adjusted or adjusted again the mechanism for phase B, or fixed it, things back to nominal. But even after this fixing and before, the trip times really did not change. They are still the same. There is no difference between before, when phase B was acting differently from the other phases, and also after, when phase B was adjusted. So timing test didn't really tell the difference between this, and this is our series of problems that could end up, after multiple operation, could end up failing the breaker, and catastrophic things could happen from this. So in conclusion, both case 1 and case 2 really timing test did not really indicate any problem, indicated that the breaker is working fine. Only motion test or travel motion test reveal these issues with the breaker. If motion test was not being done to this breaker, nobody know how long this problem could take just to damage or create problems for you with this breaker. Another thing that you can also benefit from motion test in is finding arcing contacts in SF6 circuit breakers. This is another reason. Static resistance, or what we call contact resistance or micro ohm measurement to arcing contact, is not really something applicable. Now, but what is actually arcing contact? If you took a cross-sectional picture of a SF6 circuit breaker, whether it's a GIS or even a live tank circuit breakers, you will find the contact system is actually coming of two parts. You will have a main contact, so it will be around the interrupter, and an arcing contact in the middle. The reason for having this, the main contact will be conducting the current during normal operation. It can withstand the rated current, and the arcing contact, from its name, it's made to absorb any arcs before it's extinguished during opening or closing these breakers. Any arcing happen, this arcing contact will open last or close first. When they are in operation or in closed position, and you try to do a contact resistance, or what we call static resistance measurement to them, you will have both these contacts in parallel. Since you can't really separate them, they are inside the interrupter, inside the SF gas. So the total resistance, and this is an approximate values which what you might face in the site. Usually the main contact is very small, and the arcing contact is high values in the milli ohm values. If you did a parallel calculation to them, you will find out that the arcing contact is really negligible. So you can't really find the value of that arcing contact. Only the main contact is shown here. From the 30 parallel with 1000, you find 29.12. So really the 1000 is not really showing that much. So if there is any problem with the arcing contact, you cannot find that using just normal contact resistance test. So how do you do that? You do that using something called dynamic resistance measurement. Basically trying to cancel out the value of the main contact. Try to open the breaker and once only the arcing contact touching each other, trying to capture the measurement. So in that case, if there is problem increase in the arcing contact resistance, you can really measure it. And this test is done during operation, so you have only small window to measure this arcing contact resistance value. Now, that's the name, you find it, dynamic resistance measurement. But let me tell you, if you try to do this test while opening the breaker, finding the resistance while it's opening, even if you have a very high accurate device that can sample many samples and high resolution and all that, the curve or the resistance value will show something like this. A resistance value in the blue, it's increasing, then you will find a certain jump, and then it will go to infinity after opening the breaker. Now, this thing here you have in the middle is the resistance, you can say, of the arcing contact, which is something you can't really get a good value from. It's going up and down and up and down, and so this is the closed position at this area. This is the arcing contacts only, and then it's the open position. So it is very difficult to find an easy number that you can use to really indicate whether you have a healthy or bad arcing contacts. So how can I solve this? How can I make this measurement better? Guess what? You use motion test with DRM test. In addition to the DRM test, you add travel motion test as well. Now, with the addition of a travel motion test, you know that in this jump period where you have the resistance value only indicating you have an arcing contact touching, you have the value of the distance. Now, the distance from the beginning of the arcing contact until the end can really give you the length of these two arcing contact touching with each other. So you can measure the length of these arcing contacts even without opening the breaker, which is something very tedious, and especially if you have SF6 gas, you have to handle it, you have to empty the tank and all that. So both, for example, for the fixed and moving contacts in your circuit breaker, you can find if there is any problem or wearing in them by doing this DRM plus travel motion test. And this is an actual case that what I showed you earlier from a breaker. And once they opened a breaker, they found out that the contacts have weared out after a huge short circuit current. This was, I believe, a generator circuit breaker case. So, and many more examples and problems can be really revealed by a motion test. For example, you can find if you have incorrect stroke length, it is or traveling more or less than it should be. If you have wrong open or close velocity, it's moving much faster or slower than what is defined. You have a problem maybe with lubrication, with the springs. If you have a pressure problem with some type of mechanisms as well. Excessive arcing contact wear, this is using the DRM test. If you have any problem with that, you can view it also from combining the DRM plus the travel motion test. Another things, for example, too early damping or a lot of rebouncing at the close or opening. This could ignite or create restrikings of arcs and could actually even explode the circuit breakers. A lot of information you are missing by not doing a motion test. So it's really very important test to do. So since we know what motion test is and why it is important, what's the information we can get from a motion test, how can we do it? How can we do this test? So when you are talking about motion in circuit breakers, or the things that is important for us, two concepts need to be understood. Is that the motion can be captured either as a linear motion and a movement of a line. This is usually a direct connection to the interrupters inside the breakers through the helpings arm you have outside, or could be an angular motion where this angular motion maybe can be measured from helping gears inside the operating mechanism. For each type of these motions, a transducer is a device that convert from mechanical movement in millimeter or an angle to electrical signal that we can store and record. So you have linear transducers or you have angular transducers. These two pictures is just a small example. There are many types or different types of or many shapes of each type of these transducers. Really, some of them is designed in general for a lot of circuit breakers, or specific to certain type or certain model or certain manufacturer of circuit breakers. Let's see some pictures about these transducers. For example, this is a linear transducers. Here I have a linear transducer kits, mounting kits. You can see there are a lot of parts help you mount this transducer. They come in different sizes and shapes and lengths to accommodate many breaker configurations. Another kit here we have is for angular transducer mounting kits. You can see the transducer is only this small part here. This is the transducer and this is the connection cables to it. But a lot of accessory for it to be mounted. You have so much different types of adapters. Some of them are long, some of them are small to be able to fit or connect to the mechanism, and also some types of hands or holders to hold the transducer in a place. I have a lot of pictures in the next slide showing examples of mounting a transducer for both linear and angular transducer. It's really knowing your breaker give you the ability to connect to the breaker mechanism. So it's a very good information to have, is how is your mechanism is operated and where is the mounting points to a transducer. A lot of manufacturers already define some mounting points and they already do the test in the factory and also maybe in the commissioning stage. So even for routine maintenance, you can do this test as well from the same point. So you can get a consistent result with what they get in the commissioning and factory acceptance testing. So the first thing here, I have a bulk oil breaker. I know these are quite old now and obsolete, but some of them still exist, and this is a good example. I have my linear transducer with direct connection to the interrupters. It's available in the top, and this is a zoomed in picture for it. You can see the transducer arm. This is small arm here, and it will measure what's it's go up or down the open and close operation. Another picture, this is for a minimum oil breaker, as well for a linear measurement transducer. This is a picture for an SF6 dead tank breaker, where they connected the transducer, a linear transducer, but not directly to the mechanism, which you can see the interrupters behind. It's not connected to it, but to a helping arm here. You can see this arm, and the transducer is connected to it. This arm rotates like this or this, and this will move the arm in the transducer. So this is, we can call it an indirect connection to the interrupters or contacts inside the breaker, but still a major value that we can get, and we can maybe do some analysis with it further on. Another SF6 gas dead tank breaker. You have this dead tank breaker and the mechanism here, and there is the transducer connected below there. This is a zoomed out picture of it. This is now not a linear connection, but an angular connection or mounting to the breaker mechanism. So this arm rotates, this arm rotate and help open or close the breaker. This is an helping arm to it. So we connect it to the gear controlling this arm in an angular motion. So we are capturing the angle from the start to the end of the rotation using this transducer. And now the transducer, in order to get a correct measurement, we use a coupling adapter and also a coupling bearing to minimize any problems with misalignment, and also an holder arm that holds the transducer and all its weight, so it doesn't hold on the gear itself. This is another angular measurement to this live tank circuit breaker. I believe this was done inside the manufacturer site, but still a good insight. You can find it here. This mechanism is rotating. You can see the arm going in and out. This arm is controlling the three balls of the breaker, or the three phases, and you can really see the measurement value for it by connecting to this rotating arm. So here you have this gear to go inside or outside depending on opening or closing the breaker. Another picture as well to give you a more example on mounting angular measurement. So you have here another live tank circuit breaker or SF6 circuit breaker, where you have the arm here moving connected to it, and this is another to these breakers. I just added the coupling adapter and transducer, and then connected through a wire to my circuit breaker analyzer or tester to get the motion test. Another picture as well. This is, I think, yes, it is a Siemens 8DN9 in a 220 kV. So this is one of the phases. Each phase has its own operating mechanism. This is one of the phases, and you can see the transducer is connected here. This is another angle of the measurement as well. You can see it's coupled using a different coupling style. It's more of a round shape coupler to the mechanism itself. Another transducer, angular transducer, is connected below here and was held using this holding arm. So it's not really something difficult to mount a transducer. I know some people might feel scary to do it at the first time, but with the help of the manufacturers, they should really give you a very easy where to connect each type, or each, depending on each circuit breaker, where is the mounting areas, as they have done it in the factory acceptance test. So from what we've seen so far in the mounting pictures, some connection were made directly to the interrupter, and the measurement directly can be captured, and some of them are not directly or indirect through a helping gear or arm or whatever. So we really, the measurement can be either direct or an indirect measurement. The difference is that a direct measurement will capture the real stroke. I don't have to multiply it by any table or any factor or whatever, and it will be the most accurate. The motion will be clean. There is no distortion from any mechanical play because of these gears or because of misalignment or anything like that. So it's the best way to do it, really. But the problem with direct measurement is not always possible. Not all breakers, especially if you're talking about GIS systems, it is really compact, so it's not always possible to mount your transducer on the actual mechanism or the actual arm of the interrupters. So that's why we refer to the indirect measurements, as it is possible on most circuit breakers, but it will require you to have a factor, or in many cases a table, even a full table, and I will explain the difference between them, to be able to convert from this indirect to directly what is the measurement of the actual contact movement. So this really give you 4 or different measurement options that you can use to do the measurement. You can either go with an absolute measurement, the actual direct. If it's possible, go ahead for it. And this absolute measurement, you can get it either as a distance or angular value, either in millimeter or in degree directly. Or you can go with an absolute measurement, but with a linear conversion factor, where when you have an indirect measurement, you can just multiply it with a factor, if you know that factor, and I will show some example for that, and you will get the actual moving contact. Or you can do an absolute measurement with a conversion table. Now this conversion table is the most really difficult thing to find, because this is something I believe only the manufacturer can give you that. It's by measuring the indirect measurement, and then this measurement depends on where in that measurement you convert it to a distance value. Or the most easiest and simplest way is to just take a relative measurement. You define a nominal stroke, you know how much is the full stroke, and you say the beginning and the end of my stroke is just a relative value. But this relative measurement does not really give you the actual stroke value, since you are not doing any absolute measurement. So just to give you an example of this linear conversion or conversion tables, this is an example of a very simplified example of a moving and fixed contact. Here I have a moving contact and a fixed contact. So this is my two circuit breakers interrupters. When this moving contact closes, my transducer will go up, and when it's open, my transducer will go down. But I'm not capturing this up and down directly, but I'm capturing it through a helping arm. Now, I know if you know a little bit about simple physics, you can really calculate a factor between this long arm and short arm that I'm connecting my transducer or mounting my transducer on. And from that, I can just divide these values and multiply it in the value I get in my transducer. It will give me what is the actual moving and fixed contact value. Another example is for an angular motion. Here I'm measuring an angular motion. I have an angular transducer that is connected to a gear controlling an arm. Now this arm is moving in angular shape like this. Now just by finding the radius or starting angle to the end angle, I can find the millimeter value that this contact is traveling. And this linear factor is done using a small conversion table that just have three values: a start, a middle, and an end value. And this start, middle, and end value really gives you a linear motion. So this factor is linear. Whether you start from here or from there, it will always give you the same factor. Now, this is not always the case. Most cases is using the other way, using a full conversion table, where, for example, in this angular transducer, the motion is not really linear with the angle that is being measured. So in this case, at this angle, the millimeter value is different than at this angle if I started from there. So the motion movement is not linear. In this case, I will have to have a long table with multiple values. For example, here the table size is 841 as a conversion table. And for each range, I defined what is the millimeter values. So to give you even more explanation about this, for example, from angle 10 to 1, I can have the change as 1 millimeter per degree, and from above that I can have the change to be half of millimeter per degree. So this is what's the table functionality to do, to able to give you a better resolution that change dynamically with the angle that you are measuring. The transducer could be really defined by different technologies. This is what electrical signal coming out of the transducer. It could be an analog signal as a resistive. You can measure the resistance of the transducer as a motion. It's the same as RTDs, or used to measure heat by a resistor, or as a voltage output from 0 to 10 volt. I can measure it depending on the position of the transducer. The voltage will change in the transducer. Or as a milliampere current, usually 4 to 20 milliampere current. So whenever the motion change in this transducer, one of these values, whether it's a resistive voltage type or current type, will change accordingly. And I can find the whole length by finding the first position, then to the second position of the voltage or current or resistance, and take the conversion of motion from that. Or the other type you have is a digital type, where the output is not an analog value like a resistance or a voltage or current, but it is number of pulses. The number of pulses really gives you where is the position of the transducer or have moved. And these transducers are usually cheaper than the analog one, because the pulses mechanism can be registered much easier and does not require as much as accuracy as the analog type transducers. So in the end, this is some example result for close operation. For example, here I have my timing lines. It was open and then become closed, and this is my auxiliary contact 52A, 52B. It's ready to close. Once it became closed, it become ready to open, and on top of them is the measurement. This is starting from open position going all the way up to the closed position. It's not only graph that you can see, but also as a parameters. Here I have my stroke value. Here I have my speed, the speed of the movement, and you can see the two dots here defining the calculation points of the speed. If I have any trouble, over travel in millimeter, I can have that, and also in degrees. Any rebound showing it also will be measured for you and given as a value directly. This is an example of an open operation now instead of close. So it was in a closed position and then go to open position. The graph and also the parameters. Then you have another operation, a close open operation. It was open, then become close. I give a close command and closed, and then immediately I give an open command. This is what we usually refer to as switch on to fault. The breaker was open, I closed it, and there was already fault in the line, and I immediately open the breaker. Now, one important parameter that I did not talk about is the speed. You can see there is these 2 points. These 2 points really depend on the type of mechanism or motion that you are doing to be able to measure them. This points, you have an upper and lower points either for closing or opening operation, need to be defined depending on the manufacturer recommendation. There are different types of definition for these 2 points. The upper and lower point, you can define them as distance being closed as this much value, or at contact separation, or a time after the upper point, to give you the most optimal value. And the reason for that is that the motion curve, if you can see it here, it is starting as a curve and then become a linear one. The reason for that is because at the beginning of the motion, it is accelerating until it reaches its constant speed. So it's not a good thing to measure the speed from points during the acceleration. We just want to measure them from points during the constant speed to give us a constant value that we can analyze later on. So a lot of these transducers can be used with our circuit breaker analyzer, either analog or digital, can be used with our advanced circuit breaker analyzer, the TM1700 or 1800. If you have the EGL unit, which is more designed for the medium voltage breakers, make sure you have the analog option. It's having motion transducer in it. or motion input to connect the transducer to be able to capture this measurement from. I would like to thank you all for joining us today. And let's see some question and answer this question for you. Sanjay, is there any question?
Yeah, Ali. Ali, are you there?
Yes.
Thank you very much, Ali, for this presentation. So we'll wait for the question and answer session.
Uh-huh. I see there are some questions. I feel there is one in Arabic, so I will read that one.
Okay.
So basically, that question is asking: is the place to mount the arm depending on the manufacturer هل مكان تثبيت الذراع يختلف حسب المصنع؟ The question is asking whether the mounting place depending on the manufacturer. I will tell you, it's not only the manufacturer but even the model. Sometimes even from one year to a different year of the same model could be different as well. So let me go back, and all these examples that I showed you, it's from an actual breakers. Let me show that particular pictures here. It really depends on the type of the mechanism. So even from the same manufacturer, you can have different models. One model is SF6 live tank circuit breaker. One model is Dead Tank. Another model is GIS. All of them might not have the same mechanism. You might have different types of mechanisms. So for that, you need to know your mechanism and then find out where. And after that, you can obtain a transducer that can fit or mount on that mounting area. Just open the mechanism and just operate the breaker. Just be careful with that. Apply common sense and see what is the parts that you can connect to. Usually it's an handling arm or a gear that is rotating, moving an arm to connect the transducer or mount the transducer to. Another question I see here is please share any example of motion calculation for angular measurement. I think you are referring to the conversion tables, if I'm not mistaken. The conversion tables, this is an actual example of it. So this is the, I would say, the text I have on a conversion table file. This table is inputting an angle value and outputting a millimeter value. So I'm changing from, I'm converging from angle to millimeter, which is more beneficial for me to have a millimeter value. And each measurement is in the interval of 0.1 angle. And then I have the table size, I have 841 values. So this degree I say the millimeter is this much. At this degree is this much. Oh. At this degree is this much, and so on and so forth. So it's really you can define it yourself, and you can see that. Please explain how to use TM1800 for this test. I don't think time will allow me to explain this in details for you. Could you please drop me an email? I will share my email, and maybe we can have an one-on-one session, and I can give you an example on how to do that, and also show you maybe a practical way, open my camera and show you that. So if you would please send me an email to that, and I will give you more explanation on that. It would be my pleasure, really. Another example or another question is, can you compare test results if different methods is used? For example, one by different contractors, or must be using the same method for future comparison? I would say that you could do that, but if, for example, someone doing was linear measurement before, and then you could not do linear measurement for accessibility problems, for not having the linear transducer, you have an angular transducer, and you could convert this angular motion that you have measured using a conversion table to a linear motion. Yes, you can compare the result, for example, for the stroke, for the speed, even for rebound values and penetration. I believe you can do that. Yes. Is there any other questions available in the chat? For example, Sanjay?
There are no questions. I think you have taken all the questions.
Yeah, very good, very nice. Regarding that person who sent me his email address, I will copy that email and maybe have a separate meeting or email with you to explain that further for you. One thing I would like to note out is that this presentation is available in the handout section. You can download that file for reference.
Okay. Thank you all for attending this webinar, and thank you, Ali, for giving such a great presentation. And please do follow us on Facebook and LinkedIn for regular updates about mega products and other information. And also register yourself for the upcoming webinars. Thank you once again, and have a nice day, and we will see you in the next webinar.